Hello. Today what we're going to try to do is follow the path of the sun through a typical 1 year period, showing you the differences between it happening directly from the east to the west, where most people actually think the sun rises and sets. But we'll also find out that the summer sun rises way on the north side and the winter sun rises way on the south side of east. And then every particular day about one little section a little farther to the north, all the way back to spring, and then it just keeps going farther and farther and farther, a little bit each day, all the way to summer, where it stands still, called the solstice, and then it works back this direction to get to the equalizer, which is the equinox, equal day and equal night for the entire period, and then works its way back to the other solstice, the winter solstice. So what I'm going to do first is I'm going to draw a couple of suns. I'm going to draw one right here. I'm trying to pick a nice yellow color for the sun. That's going to represent the sun as it rises directly east 2 days out of the year. We'll actually talk about these dates in a second. Going to draw another one way out here. Going to draw one way inside. And then I'm going to do the same thing on this side. Drawing them in those three locations. One for the winter solstice, one for the equinox, spring and autumn, vernal and autumnal, and then one way over here for the summer solstice. Okay, if we look at the 4 dates that are shown here, December 21st, if I go over here, and this represents the winter solstice. This is the summer solstice. This right here is the vernal. Equinox. And this one over here is the autumnal. Equinox. Okay, so these are the seasons we're talking about. We're going to go ahead and start with the winter solstice. The winter solstice actually begins right here, where we actually get a sunrise. If you take a look at it, somewhere between 7 a.m. and 8 a.m., we're going to go ahead and say that this is 07:30. Now we do have to differentiate between two things. We have what is called Eastern Standard Time. I'm actually right around the DC area. If you're in Mountain or Central or Pacific, you got the same thing. Standard Time basically is the time it's supposed to be, using the 24-hour variation clock. And we also have something called Eastern Daylight Savings Time. We'll be entering this thing, I think, in the next week. Basically what that does is it takes an hour and it actually makes it disappear. I think 1 o'clock in the morning becomes 2 o'clock, or 2 o'clock in the morning becomes 3 o'clock. But that's going to tend to change these times. These are all listed in Eastern Standard Time. So that's important to remember, especially when I start talking about this right here. It's going to actually say that it rises. If you look at this is 7, this is 6. It's going to raise itself at 4:30, but on the clock it really would show 5:30, even though if we used Eastern Standard Time it would be at 04:30. Excuse me. Okay, let's get back to this chart. Okay, we've got this sun rising located right there. It is on the south side of east. Southeast is probably right there, so it's actually on the east side of that, and this is actually pronounced east, south, east. If we did this with declination, or we did this with right ascension, right ascension, or if we did this with azimuth, we'd be saying that this was 180, this is 90 degrees, this is halfway in between. We could actually give it a numerical value, but we're just going to say that it's east-southeast. Okay, as it rises, it's going to move across the sky, and it reaches this magic line called the meridian. And remember, when the sun is located right there, let me pick a sun color. I'm going to pick a different color for the sun, a little more obvious maybe. When the sun is right there, we actually have this sky divided up into two sections. This is the AM side, standing for anti-meridian, and this is the PM side, standing for post-meridian. So if you ever wonder what AM and PM stands for, that's it. Anti-meridian, which is the part of the sky that follows after the sun, and we have the post-meridian, which is the side before the sun. But when it actually rises and it gets to that point, highest point in the sky, and it is arcing out of the eastern horizon, it moves into the southern horizon, sets in the western horizon. When it gets to this point, it is at its highest point. We're going to get that down here. In fact, you can see altitude really should be 23.5 degrees, but we're going to say it's 25 degrees. So 25 degrees, and I probably should keep that in a constant color. 25 degrees. Okay, at noon, it's actually directly south, and in terms of time, it is sitting right at 1200 hours, 12 noon. Then it's going to move across the sky, getting lower as it's arcing down towards the western sky. It's going to get to this point right here. Sunset is going to happen at 4:30, but we have to write 16:30. And it's going to actually be south of west. It's going to be west of that, so it actually sets at west, south, west. How many hours of daylight do we get? Well, we have 1, 2, 3, 4.5 hours before, and 1, 2, 3, 4.5 hours after. We get 9 hours to heat up. 24 minus 9, we get 15 hours to cool down. Why is it cold in the winter? Basically two reasons you can see from this diagram. One, sun doesn't get very high in the sky, and if you think about it, if you get a sun high in the sky, you get a whole lot of direct radiation. You get a sun that's lower in the sky, you get less direct radiation. So not only do we get less direct radiation, we also don't get as many hours in the day. Okay, we move over here about 3 months later, March 21st, maybe 22nd, and we get the sun rising directly out of the east. It's the only day, other than when we move over to this autumnal equinox, September 23rd, only 2 days that the sun really rises directly out of the east. What time? 0600. Then it's going to arc across the sky, and you can actually see the little circles that are drawn here showing you the sun's progression. It goes all the way out to 50 degrees, as high as 50 degrees. And if you actually go from the 50, you see 60, 70, 80, 90. This 90, if you're thinking about this as being a three-dimensional celestial sphere or a three-dimensional sky dome, this is going to be directly over your head. So it's kind of hard to imagine it here, but it goes directly over your head. And again, the meridian goes from the south compass point up through your zenith, back around to Polaris, which would have been sitting right around here for us, right around 39 degrees. And then to the north compass point, which we're going to say is actually way down here. This would be the north compass point. So that's the meridian. Things actually arc up. They get to the highest point when they cross your meridian, and then they arc back down. Your meridian is always from the south to the zenith to the north. The meridian does not move. Things cross, celestial objects cross your meridian. Okay, so noon still going to happen at 1200 hours. And it's still going to be a southern location. Sunset, it's going to happen way down here, 6 o'clock p.m., but to keep it in relation, 1800 hours. And it's going to be directly to the west. And for us and the entire planet, 12 hours to warm up, and 12 hours to cool down. Again, this is the equinox, the one time where the entire planet has the same sunrise and the same sunset. And that actually works for all the way up from the North Pole to the South Pole. And it'll be the first time the North Pole actually sees the sun since they kissed it goodbye back in September. June 21st, okay, my actual anniversary. Real nice way to remember anniversary is because I love geoscience, and it is the longest day of the year. Sun rises at 04:30. What direction? It's on the north side of east. Northeast would be there. It's actually on the east side of northeast. So it's going to rise at east, north, east. It's going to move across the arc up, moving across the sky, southern direction. It'll actually cross your meridian way the heck up there. It'll actually happen. It's in the southern part of the sky. It'll happen at the same time, 1200 hours. And then it's going to arc back down towards the western part of the sky and set way over here. And again, we have northwest way over there. It's on the west side of that. So it's actually going to happen at west, north, west. And it's going to happen at 7:30. It's going to be at 19:30. We have 1, 2, 3, 4, 5, 6, 7.5 hours before and 7.5 hours after noon. We get 15 hours to warm up, 9 hours, 24 minus 15 to cool down, and the sun gets all the way up to, we're going to say 75 degrees. It's actually just a tad lower than that, but 75 degrees. Why is it so warm in the summer? Well, we get a lot more of that direct radiation, and we also get 15 hours for that warm-up period, and only 9 hours for it to cool down, so it should get warmer, warmer, and warmer. Just like over here, it's going to get colder, colder, and colder. Okay, September 23rd, times are exactly, directions are exactly, hours and degrees exactly like they were in March. Sun's going to rise at 0600. It's going to move at 12 noon. 1200 hours. It's going to rise directly out of the east. It's going to be in the southern sky at noon. It's going to set 1800 hours directly to the west, and once again providing the entire planet 12 hours of sunlight, 12 hours of darkness, and once again it's going to be at about 50 degrees. Okay, that in a nutshell is how this thing is actually going to work. Appreciate you listening, and we'll see you guys soon. Bye.